Okay, let's look what we have on this problem. Write the following in sigma notation. Sigma notation. When we say sigma notation, it should be in this form. K is equal to maybe 1, n, and the general term. So we need to first find the general term. Then we'll use that general term to find the value of n. So we need to test what type of series is this, but we can see that the difference between these two numbers is not the same. Like the difference between 10 and 2 is 8, and the difference between 50 and 10 is 40. So this is not a linear. We're going to check for quadratic. So to check for quadratic, we need to check the value of r. We need to check if this has a common ratio of t2 divided by t1. So the value of t2 is 10. Divide this by 2. What do you get? The value of r is equals to 5. Is this the same when you say t3 divided by t2? If you get the same, then you can conclude and say this is a geometric. So r is equal to t3, divide that t3 by t2. So we're going to take the 50 divided by 10, which gives us the value of r as 5. Therefore, we can conclude and say r is equal to 5, and the value of a is the first term of the sequence, which is 2. Remember, because we have a common ratio, this is a geometric sequence. So, since it's a geometric sequence, remember the general formula for a geometric sequence is Tn is equal to a multiplied by r to the power n minus 1. You just have to substitute the value of a and the value of r. So this will give us Tn, it's equal to the value of a is the first term of the sequence, which is 2, multiplied by r, which is 5, and everything is to the power 1, n minus 1. This is our general term. The general term is just 2 times 5 to the power n minus 1. We need to use this general term to find the number of terms. Remember here on top, we put the number of terms on the sequence. So we need to say that Tn, where there's Tn, you substitute the last term. As you can see, they tell us that the last term is this big number. So from the formula, Tn is equals to 2 times 5 to the power n minus 1. We need to substitute what? The 781,250, equate this to 2 multiplied by 5 to the power n minus 1. So now we can solve for what? For n. First thing first, we need to isolate n. Let's get rid of these 2. Divide both sides by the 2. What do you get? This 2 cancels. I'm going to have this as 5 to the power n minus 1. Then 781,250. What do you get when you divide those 2? 781, we're going to say 250. We take this divided by 2, it gives us 390,625. So this will be 390,625. So now, what you're going to do is that some can use the logs to make n subject of the formula, but what I'm going to recommend is to check this big number. Can we write the 390 into base? Can we write this guy into base 5? Yes, we can. What you have to do, punch the 390,625 on your calculator, then say equal sign. Then say shift fact. So it will give you that this is 5 to the power 8. So this guy can be written as 5 to the power 8. So this will be 5 to the power 8 is equal to 5 to the power n minus 1. So why do we need to change that 390,625 to be 5 to the power 8? So that we can have the same base. Remember the laws of exponent. When the base are the same, what do we do to the exponent? We equate them. This will be n minus 1 is equal to 8. So if you bring the 1 to the other side, what is the value of n? The value of n is 9. So this tells us that this sequence has 9 terms. So if we write this equation in sigma notation, what will be our answer? Our answer will be the sum. We put the 9 on top and the general term. Our general term is 2 times 5 to the power n minus 1. So we are missing something, the bottom number. So this bottom number, it tells us if our sequence starts at 1, if our sequence starts at 0. So what you're going to do, you're going to test. You're going to test if k is equal to 0. So if k is equal to 0, where there's n, you put 0. I don't think this will be accurate if we say k is equals to, but let's use n, because if n is 0. So if n is 0, what do you get? So we're going to say t0, what is that equals to? So this will be 2 to the power 5, 0 minus 1. What is the answer? It's the same as 2 over what? 2 over 5. So now, even if you just put it on the calculator, this is what it will give you. You compare this number with the first term. Is 2 the same as 2 over 5? No. So, n is not 0. You do the same, you check for what? You do the same, you check for if n is 1. So if n is 1, you're going to have what? You're going to have 2 to the power, 2 times 5 to the power 1 minus 1, which will be 5 to the power 0. Any number to the power 0 is 1. So this is just 2. So can you see that this gives us the same term? Now, this starts at n, it's equal to 1. This is the final answer of the sigma notation. Please don't forget, most important thing is to check. First, find your general term, then also use that general term to find the value of n.